Go. Go long!
Person A and person B run at each other in a straight line. Person A has a speed of 8 miles per hour going right, and person B has a speed of 6.5 miles per hour to the left with respect to the ground. If they are 0.2 miles apart, how long will it take in minutes before they run into each other? This is the diagram for my problem. So first we have to convert 8 miles per hour into meters per second, which gives us 3.57 meters per second for 8 miles per hour, and 6.5 miles per hour is 2.905 meters per second. And we also have to convert the 2 miles into meters. So we use this equation in order to find the distance, plus 321.8 meters. So we plug in x using the first equation, and we calculate the math, and the time is 49.69 seconds, but we have to convert that into minutes. So divide it by 60, which gives us 0.82 minutes. A ball is launched with an initial velocity of 20 meters per second of an angle of 45 degrees above the horizon, ignoring air resistance. Calculate the initial horizontal and vertical velocities of the ball, determine the maximum height reached by the ball, and what is the total time of flight. In order to find the initial horizontal velocity, we need to use the v cosine theta equation. We plug in the numbers and it gives us the answer 14.142 meters per second. And we do the same for the initial vertical velocity, which gives us the same answer because the angle is 45 degrees. In order to find the initial height, we first have to find the time. The time is 1.442 seconds. So we plug that into the other kinematics equation. And it gives us 10.204 meters. Finally, the total time that it takes. And the total time is 2.884 seconds.
Chelsea, with a mass of 50 kilograms, is climbing the vertical pole that is 10 meters high to get the ball. Chelsea starts from the bottom and reaches the top of the roof. Assume the acceleration due to gravity is 9.8 meters per second squared, and her initial speed is 0. Calculate the gravitational potential energy of Chelsea when she reaches the top of the roof. Determine the work done by gravity on her during the climb. If Chelsea were to slide down the roof and reach the bottom with a speed of 5 meters per second, what would be her kinetic energy at the bottom? Assume no other forces or energy losses. A. The gravitational potential energy, PE, of an object is given by the formula PE equals mgh, where m is mass, g is acceleration due to gravity, and h is height. In this case, Chelsea's mass, m, is 50 kilograms, the acceleration due to gravity is g, 9.8 meters per second squared, and the height h is 10 meters. To solve the problem, we would set it up like this. PE equals mgh, which equals 50 kilograms times 9.8 meters per second squared times 10 meters, which equals 4,900 joules. Therefore, the gravitational potential energy of the climber, Chelsea, when she reaches the top of the roof is 4,900 joules. B. The work done by gravity on Chelsea during her climb down is equal to the change in gravitational energy. So, work equals PE, which equals PE final minus PE initial. Since Chelsea starts from the bottom, her initial gravitational potential energy is 0. So, work equals 4,900 joules minus 0 joules, which equals 4,900 joules. Therefore, the work done by gravity on Chelsea during her ascent down is 4,900 joules. C. The kinetic energy, Ke, of an object is given by the formula Ke equals 1/2 times m times v squared, where m is the mass and v is the velocity. In this case, Chelsea's mass m is 50 kilograms and the velocity v is 5 meters per second squared. To solve this problem, we would set it up like this. Ke equals 1/2 times mv squared, which equals 1/2 times 50 kilograms times 5 meters per second squared, which equals 125 joules. Therefore, Chelsea's kinetic energy at the bottom of the cliff after sliding down and reaching a speed of 5 meters a second squared would be 125 joules.
That was so...
Person C with a mass of 50 kilograms retrieves the volleyball from the roof. She falls 5 meters from rest off the roof and hits the ground. She first hits the ground and comes to a sudden stop in 0.10 seconds. Then she rolls to a stop in 0.75 seconds. When she first hits the ground, how much momentum does she have at impact? What impulse does she feel for both cases? To solve this problem, first draw a diagram of the motions. Then use the conservation of energy theorem to find the velocity. In this case, it is negative 9.9 meters per second. You then plug this value into the impulse momentum theorem to find the momentum, which is negative 495 kilograms meters per second. For the second part of this problem, use the impulse momentum theorem to find impulse. In this case, MVF is 0 and MVI is negative 495, making the impulse positive 495 kilograms meters per second.